video is to help you with the Mission Critical Part D section on the Alpha Centauri project, and in that question you are being asked how much is the fuel to get to Alpha Centauri, how much is that going to cost? This is a big question because it has multiple parts to it, and in this video I'm going to walk you through each one of those parts, but you are going to have to do all the solving on your own. So the very first part of this video is actually how are we going to figure out how many rockets do we need. So in order to get to the total fuel cost, we need to start with how many rockets are we going to strap to our ship to get it going up to speed. In order to do that, we're going to be using the equation for impulse. So if you don't remember that, that's force times change in time is equal to the change in momentum, mass times change in velocity. And we're going to plug in different parts of this equation in a way that I'll show you in just a moment. The things that we know for this first part, the things that we know to solve for how many rockets, is a relatively short list. We know the mass of our command module because in the question it says ignore the mass of all the other stuff, just the command module, and this 2 million kilogram number, that was in our list of given information on the front page. We also know that our target velocity, also from the front page, is 1/100th of the speed of light, and that's not something that I'm going to solve for you. That's from one of the previous questions that you should know that at this point. We know from the givens that the speed of light is 300,000 kilometers per second, and we also know that the force from a rocket is this number on your screen, 1.668 times 10 to the 6th newtons. We got to use some scientific notation. We also know that the time for one rocket, so when the rockets are burning, they burn for 8.5 minutes. So to give you a visual concept of this, we're taking this little command module, this is in my brain, this is how I picture it, and we're going to stick rockets to it, but we don't know how many rockets. That's what we're going to try to figure out. Once we know how many rockets we're going to stick to it, we can multiply the amount of rockets times the cost of fuel per rocket, and we can figure out how much money it's going to cost. So in order to set this up, now we're going to go even deeper, and we're going to ask the question, how much momentum does the command module have? Since the equation we're using is impulse equals momentum, I've just blown this up, and I want to think about them in two parts. The momentum is going to be the yellow side, the impulse is going to be the blue side, and we're going to think about them separately to help us to understand this question. So for the momentum, we actually have everything that we need. We know that the ship is what we need to get moving. The ship is going to have the momentum, and we know that it has a mass of 2 million kilograms, so that's the m part of our momentum equation. And we also know that it needs to go 1/100th the speed of light, which it may not sound like it's a lot, 1/100th of something, but it is actually really, really fast. And when we get something really heavy going really fast, it's going to be a lot of momentum. So on the yellow side, our momentum is going to be a really large number. Well, in order to get that really, really large momentum, we have to figure out the impulse side. So how much impulse is just one rocket going to provide? Since all of that momentum came from rockets pushing on it, we've got to figure out how much is one rocket going to push on it, and then we have to multiply by however many rockets to get up to this big momentum on the yellow side. So we're going to start with just one rocket. We know, I'm telling you, it's going to be way more than one rocket, but once we figure out how much impulse for one, we can just do a little bit of division to figure out how many total. So the force from one rocket we know is this number from the givens list, and we also know that the time for a rocket is 8.5 minutes. So that's going to go into our F and our T, but remember that's just for one rocket. We don't know how many total we're going to need. So in other words, the impulse from all the rockets is going to equal the momentum of our ship. So we're going to say there's going to be a lot of rockets. All the rockets pushing together are going to equal the momentum of this ship. So if we figure out for just one rocket, we can multiply. So here's how we're going to do this. The momentum of our ship, which we know, we found the mass, we know how fast, we know this yellow number. That divided by the impulse from just one rocket, that's going to tell us how many rockets we need. Once we know how many rockets we need, we can figure out the fuel cost following these steps. Here's what we know for this step, this part of the problem. We know the number of rockets, we just solved that. We also know how much fuel one rocket holds, that's on the givens list. We also know the mass of 1 cubic meter. 1 cubic meter is imagine a cube that is 1 meter by 1 meter by 1 meter, one big cube floating there in space. That amount of volume, we know how much mass that would have, that's from the givens list. And we know how much fuel every gram of fuel is going to cost. or how much money every gram of fuel is going to cost. So we're going to take our number of rockets, that's what we figured out in green, these are all color-coded, number of rockets that we figured out from the last step, times how much volume a single rocket can hold, times how much mass per unit of volume. So at this point we now know how much mass all those rockets are going to need in fuel, times the cost per unit of mass. Once we have all these parts multiplied out together, that is going to equal us the cost for just the fuel. And that's the answer to part D. Now, the biggest mistake that I see as people go through these steps is that they forget their unit conversions. As a reminder, if I go back here for just a minute, when we were solving for the amount of rockets, remember that the information that was given to you in terms of time, that was in minutes. Well, it's got to be in seconds in order for you to get the right answer. So you'll have to do some converting there. When you figure out the velocity for the speed of light, it's given to you on the information sheet in kilometers per second. You'll have to change that to meters per second. If you don't do these unit conversions, when you get all the way to the end, it's going to come out in your cost and you're going to have a very, very wrong answer. But still, you should get something very enormous for the cost for the fuel. Lastly, remember when you solve for the cost of the fuel on these steps, that's just the fuel to get the ship going. Remember that this is an object in motion now, and when it gets closer to Alpha Centauri, it's going to have to stop as well. And one of the questions on your sheet is, how much is it going to take to stop? And you'll have to use Newton's third law for that one. Good luck.